Okay, I keep forgetting that there's more problems, okay? This is the rest of 9.5. These problems look funky because they look like something we should not be able to do. But to do them, we first have to do a little bit of old algebra. And then we can use those derivative rules that we were doing where you bring the exponent down in front. Okay, so I can't quite just bring the exponent down in front because there's a bunch of stuff in the parentheses. This involves something called the chain rule, which is way far away. We're not even there yet. I don't know what section it is, but we're not there yet. So instead, let's just remember algebra. Squared means it times itself. And then we're going to FOIL. So 7x times 7x. You don't have to write this down. I'm just doing it for you. Is 49x squared. 7x times 8. No, don't make fun of me. I'm not good at counting. Okay. I can take a derivative, but I can't count. Oh, crap. 7 times 8. 56. Yay. So this makes 56x. The I is the innards, 8 times 7x. And that's the same thing. 56x, and yours should repeat at the OI of the FOIL also. And then last is 8 times 8, 64. All right, let's write this all out and then maybe combine like terms, then take the derivative. So all of this was not the derivative. We were just rewriting it to something that is the same as what we started with, just easier to work with. So let me write this down. We got 49 x squared plus 56x plus 56x. And then this 64 is a positive, so plus 64. Okay, let's combine like terms. 56 plus 56, I got that one. That's 112x, and then plus 64. So everything we've done so far is just basic algebra. We have not taken the derivative. Now let's take the derivative. You take the exponent, bring it down in front, and multiply. 49 times 2. Oh, I should have known that. 98. X to the subtract 1. 2 minus 1. 1. Okay, keep going. On the next sucker, on this 112x, there's kind of like a pretend 1 in the air. And when I take that 1 and bring it down in front and multiply, 1 times 112 is 112. X to the 0, because you have to subtract 1 from the exponent. Then the last sucker, 64, is just a naked number. It's called a constant. And when you have just a constant, the derivative of him is 0. So that 64 just goes away to 0. All right, the next thing is to maybe clean it up. This x to the 0 just goes away because it has an exponent of 0. And then I don't think I need to put that little tiny 1 in the air because we're grown. So we get 98x plus 112. Hey, that's the derivative. Okay, exciting. So on that one, you had to FOIL first. Let's look at part B. Ooh. It's got an X in the bottom and a top and a plus sign. We haven't had that yet. Okay, so when you get to this problem, the old math that you have to remember is over here on the top right of the 9.5 tricks. It says that if you have X's on top of each other, you get to cross them out. Like this sucker says X to the 5, that's 5 X's on top. And X squared, that means 2 X's are on bottom. And then you get to cross out 2 X's from the bottom with the top. And all you get on the top is 1, 2, 3 X's. And that's another way of subtracting your exponents. 5 minus 2 is 3. Okay. But if it's backwards, let's say you have the 3 on top and a 4 on bottom. When you subtract those, top minus bottom, 3 minus 4 is -1 exponent. Okay. So let's do this one. first, it's too crowded. I think I'm just gonna split it up into two fractions. It'll probably help us see things better. So I'm gonna split it up as 11x over x. And this is legit, I'm not making this up. And then you can put a plus sign. And then now let's put 13 over x. Okay, now we're gonna do that old math. That old math says that you can cross out an x from the top and the bottom. So this 11x over x, the x is canceled, and you just have 11. Plus sign. For this 13 over x, there are no x's on the top, so we're not canceling. Instead, this is the old math of, if you have an x in the denominator, you pull it up and you make that exponent negative. Well, what is my exponent? My exponent on this x is a pretend 1. So now I'm going to use that old math of taking that x to the 1 and bringing it up by that 13. And when I bring it up to the 13, that 1 exponent becomes negative 1. Okay, so far I have not taken the derivative. All I have done is rewrite it to something that's the same and easier to deal with. Now let's take the derivative. The derivative of a naked number, 11, is the same thing as this 64. It goes away to 0. Okay. The derivative of this 13x to the negative 1, you take the negative 1, bring it down in front, and multiply. 13 times negative 1 is negative 13. X to the, subtract 1 from that exponent. Negative 1 minus 1 is negative 2. Okay, and that's your derivative. That's your answer. If your homework makes you put this x back underneath the fraction, since we started out with a fraction, super easy. We just go backwards. We take this x to the negative 2 and put it underneath this 13 because it has a negative exponent. So the negative 13 stays there, but the x to the negative 2 goes underneath and becomes positive. So either one of these are good for me, but you might want to press similar exercise to see how, or not similar, you might want to press view an example to see how your homework wants it. Okay, let's go to this C. It looks the same-ish, only more bigger numbers. Okay, so we're going to start off the same. We're going to split it into two fractions. 4x over 12x to the 5. Minus sign. 3 over 12 x to the 5. Okay, now we're going to use two kinds of old math. We're going to subtract our exponents. Okay, let's go. For this 4 over 12, this x on the top has a 1. So let's subtract these exponents. 1 minus 5 is x to the negative 4. So 1 minus 5, that's equal to negative 4. So that's why I have x to the negative 4. If you don't like that way, let me show you another way. X to the 1 means there's one x on top. X to the 5 means there's 5 on the bottom. Now you get to cross out something. Okay. Let me go ahead and put the 4 and 12 on there so we don't panic. Okay. Now you get to cross out an x, and what do you have left? 4 over 12 with 1, 2, 3, 4. 4 x's on the bottom. And our old math tells us, hey, if you have an x on the bottom, you can pull it up to the top and make it negative. So that's why I have x to the negative 4, because I took this x to the 4 and I pulled it up to the top. So x to the negative 4. Now, maybe we can reduce this 4 and 12. Okay. I think you can divide them by 4, so that makes 1 over 3. All right. Let's look at this sucker. I cannot cancel anything because there's not another x on top, but I can use that old math of bringing that x to the 5 up. So this becomes negative 3 over 12, x to the negative 5. Then let's reduce this 3 and 12. I think you can reduce by 3. So divide both pieces by 3 and you get 1 over 4, x to the negative 5. So far I've not taken any derivative. I haven't done any derivative work. All I've done is cleaned it up and rewritten it the same as something else that I know how to take the derivative of. All right, let's derivatize. We're gonna take this negative 4 and bring it down in front and multiply it. All right. So I'm gonna have open parentheses, negative 4 times, what are we doing? 1/3. You might not have to put all these parentheses. Okay, press math, enter to get a fraction back. And I got negative 4 over 3. So when I take this negative 4 and bring it down in front, I get negative 4. Then I have to times it by that 1 over 3. Then I rewrite the letter x and I subtract 1 from the exponent. So negative 4 minus 1, negative 5. Then I already did this part in my calculator. Negative 4 times 1 over 3, that was negative 4 over 3. Okay, lastly, since I started with the x in the bottom, your homework might require you to have an x in the bottom. So I'm going to throw this x to the negative 5 back underneath and make it positive 5. Oh, I forgot about this one. Okay, let's do this problem. This piece, we're going to take this negative 5 and bring it down in front and multiply. So we're going to have minus 1 over 4, parentheses, negative 5. And it's okay that I wrote them kind of backwards. Like this time I wrote the 1, 4, then the negative 5, and earlier I wrote the whole number, then the fraction. It's okay that those are flopped, as long as they're multiplying. Okay, so x to the subtract 1 from the exponent, negative 6. Okay, now we're going to multiply this negative 1 over 4, negative 1 over 4, negative, times negative 5. I got 1.25. Let's math enter that beast. And I got 5 over 4, a plusative. So I'm going to put a big fat plusative 5 over 4. And then let's see if I can do some old math. Oh gosh, here's some more old math. Okay, if I have x to the negative number, I can go backwards and put it underneath with a positive exponent. Woohoo! Done with that problem. Okay, we're done with 9.5.